This is the introduction to section 3.4, part 1. And we're going to talk about two things here. We're going to prove theorems about parallel lines, and we're going to use properties of parallel lines to find angle measures. Okay? So, first thing we're going to talk about here is we've got some new theorems. We've got 3 of them here. Okay, 3 of them. And the very first one we're going to talk about here is theorem 3.7. It says if two lines are parallel to the same line, then they are parallel to each other. So, first one says if A is parallel to B and B is parallel to C, so A and B are parallel, and then C and B are parallel, then A and C are parallel. Now you'll notice if you look at this closely enough that this is very similar to another property that we've had. This is very similar to the transitive property. Okay, so what we're saying here is that it's similar to the transitive property. If two lines are parallel to the same line, then they're parallel to each other. So A would be parallel to B, B is parallel to C, then A is parallel to C. Okay, you can think of this very easily as, you think of streets. Okay, when you think of streets in a city, you may have First Street would be parallel to Second Street, would be parallel to Third Street, so forth and so on. Kind of like in Omaha, Dodge is parallel to Pacific, and Pacific is parallel to Center Street. Then Dodge and Center Street are parallel as well. Okay, that would be an example of that property. Okay, next one. Theorem 3.8 says in a plane, if two lines are perpendicular to the same line, then they are parallel to each other. So what this is saying here is, in this picture, if T is perpendicular to M and T is perpendicular to N, so if T is perpendicular to both of the same lines, which means these angles right here are exactly the same. Now, perpendicular is a word we need to discuss here a little bit. Perpendicular means that they intersect to form a right angle. You may want to write that down in your notes. Perpendicular means that two lines intersect to form a right angle. So you'll notice these angles are corresponding angles. Well, if corresponding angles are the same, these two lines are parallel. That's why M and N are parallel then. Okay? So, it essentially creates corresponding angles. Okay? So it creates corresponding angles, which is why the lines are parallel. If two lines are perpendicular to the same line, then they are parallel to each other. If M and T are perpendicular, N and T are perpendicular, then M is parallel to N. Okay? So, for example, again, the easiest kind of way for me to think of this is use streets. This would be T Street right here. T Street is coming down. It intersects M Street at a 90-degree angle, so it's a perfect right angle. Well, it also intersects N Street at a right angle, so therefore M and N are never going to touch each other. Those streets are never going to intersect, ever. They're never going to meet. Okay? And then it comes to the last one, Theorem 3.9. Theorem 3.9 says in a plane, if a line is perpendicular to one of two parallel lines, then it's also perpendicular to the other. So in this case right here, what it's saying is if this N transversal N, is perpendicular to L, and L and M are parallel, it's also perpendicular to M. Okay, because again, in order for these two lines to be parallel, these angles have to be congruent. Again, very simple to corresponding angles. So, as you look at this, okay, it forms corresponding angles again. If the transversal is perpendicular to one of two parallel lines, then it's also perpendicular to the other line. Okay, so N is perpendicular to L and M are parallel, then they're also perpendicular. Okay, again, another example would be to use a street. If N Street is perpendicular to L Street and L and M are parallel to each other, then it's also going to be perpendicular to M. Okay. Okay, now this is not in your notes. I want you to add this to maybe the back page or a blank page. So take a few minutes, hit pause, and write this down. And then I want to see if you can do your own picture. Okay, so hit pause, write this down, do your own picture, and then restart it, and I'll show you what it should look like. Okay, now that you've gotten this written down and you've paused it and tried to figure this out on your own, it says here, draw the map of a town to meet the conditions below. Based on the map, explain how each street is related to other streets. Assume all streets lie in a plane. Okay, so the first sentence here, the first one that it says, is that First Street is parallel to Third Street. So we're going to take and make some streets here. And we're going to say that this is First Street, and we'll move this over like so. And we're going to label this guy. This guy is First Street. And as a matter of fact, let's do this. Not sure I like that line, so let's use this line. There we go, that's a better line. So that guy right there is going to be First Street. Okay, and I'm going to label this guy. That guy's First Street. And it says it's parallel to Third Street. So now I'm going to draw another line. And let's put Third Street down here. We'll move it over like so, and we'll label it. Okay, so these guys are parallel to each other. Okay? Second Avenue then is parallel to Third Street. Okay, so now if I come in and draw Second Avenue is probably going to go in between these two. Usually the streets go in numerical order, so now move this guy over like so, and we'll say that this is Second Street. And Second Street is parallel to Third Street. Okay? The next one, Third Street is perpendicular to Main Street. Okay, so now this one, Main Street is perpendicular to Third Street. So if I'm going to draw this one, it's going to go up and down because it's got to be perpendicular. So it's going to form a right angle here. So I know in order to form a right angle, it's got to show that. Okay, and we'll label this guy, again, this is Main Street. Okay, that's Main Street right there. And it's perpendicular to Third Street. And then the last one says, Main Street is also perpendicular to North Avenue. Okay, now I'm going to draw North Avenue. If it's perpendicular to North Avenue, it's also going to be then parallel to all these others. So my picture is going to look like this on my next one. Make this one a different color. We'll call this is North Street right here. It's kind of hard to see in the yellow, but it'll work for now. That's North Street, and it is also perpendicular to me. Okay, now the thing is it's asking, based on the map, explain how each street is related to each other. Okay, well, in this case, you can say that First, Second, Third, and North are all parallel to each other. Okay, here's a couple reasons why. It said North and Third were perpendicular to Main, so therefore North and Third have to be parallel to each other. It also said First and Second were parallel to each other. First and Third were parallel to each other. First and Third were parallel to each other. And Second and Third are parallel to each other. Therefore, First and Second have to be parallel to each other as well. So all three of these are parallel, and if the three of them are parallel, they're also parallel to the fourth one. The other thing that you know is that Main is perpendicular, that's an upside down T, that's the symbol for it, to all streets. Okay, Main is also perpendicular to all streets. Okay, this gives you kind of an example of what you might be looking at in terms of practice for 3-4 Part 1, dealing with the new theorems. Okay, this concludes 3-4 Part 1. Make sure you complete your WSQ when you are finished.